Okay, so we are going to look at a process called completing the square. Before we do that, I want to orient everyone to our algebra tiles. So the yellow square tile represents x. I'm going to use a dry erase marker to mark that with an x just so that that's clear. Oh, actually, I'm sorry, that's x squared. And that's because the length and the width are both x. So if I put one of these little skinny yellow tiles up next to it, they have a length of x. So I'll represent how we get the x squared. This length is x, this length is 1, and then over here I have a length of x and a width of x, so that's x squared. So these little ones are x's. I'm going to mark a few of those so I can use them, because I like them to say what they are. I think it helps, and then we can wipe them off later. And then the little green tiles are just ones, and we can mark those if you want to, but they're tiny and it's hard to write. So each little green tile represents 1. So this would be a polynomial. This would be x squared plus 2x plus 1. And this is the simplest perfect square trinomial that we can make. So basically, when we're making a square, when you have a square trinomial, what we do is we actually use these and make a square. So you put 1x on this side, 1x on this side, and then the 1 fits neatly down there. But not every polynomial makes a square. So we're going to see how we can build a square. So I am going to change what I have to be x squared plus 8x. And we're going to put plus a blank. So I need to have 8 x tiles. Hopefully I have that many, barely. If you need some more, Holly.
Yes, I do.
Okay. Okay. So let me see.
I need one more.
And let me show you. I have 1, 2, 3, 4, 5, 6, 7, 8 x tiles. And what I'm going to try to do is I want to make this into a square. I want this to factor as x plus something squared, if we're thinking of this algebraically. But when you do this with actual shapes, it actually makes a square, which was cool. The first time I saw this, I was like, it made sense for the first time. So what you do first is you're going to split your x's in half, because if we're going to make a square, we've got to make our length and width the same. So they'll go this way and this way. And we need to figure out, we may not have enough little green ones, but we can see how far we get. We want to see how many of these it takes to fill it in. So there's 4. I got to be a little faster here. There's another 4. And I might run out. Oh, no, I've got just enough. So not all of these kits have enough, but I'm just visualizing. So if we think about it, it makes sense that we had 4 this way and 4 this way, and that we would end up with 16, because what's 4 times 4? It's 16. So the number that it takes to complete the square is 16. So I'm going to put that in this blank here. And then to figure out what it is, I'm going to look at what my length and width are. Well, this way, if I'm using these dimensions, I have x, and then the width of each of these is 1. So it would be plus 4, and it's the same the other direction. X plus 4. And so that's what you would get if you factored it all the way down, is x plus 4 would be the side lengths. So it actually makes sense. So let's do another one. Let's change this up, and we'll make our original problem say plus 6. And we're going to try to figure out just, so I'm going to take 2 of these x's away, and I'm going to take a bunch of these little 1s away, and then I'm going to neaten this up so it actually looks like a square. So we added 1, 2, 3, 4, 5, 6, 7, 8, 9 to this. And then when we go to factor it, this distance across here, this distance is x. And then I have 1, 2, 3 this way, so plus 3, because the width of this is the same as these, it's 1. And then this way, it's x plus 3, and we get x plus 3 times x plus 3 is x plus 3 squared. Okay, so how am I going to use this to do other stuff? Let me put this aside. It's kind of cool just to see that this works. Sometimes it's not whole numbers, and sometimes we end up with negatives, and so that can be interesting. So I put my title up here, completing the square. I'll put my date and stuff on there later. But we're just going to put a couple of examples. If I have a binomial, so the first one that we did was, yes, I am off the screen, thank you. The first one that we did was x squared plus 8x. That's what we had. And what we were looking for first was this number. So when we think about ax squared plus bx plus c, this is c that's missing. So a lot of times they'll say, find c such that, blah, 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 blah. So if we think about what we did with the squares, we took our 8x's and we split them in half and put them on both sides. Mathematically, that's what we're going to do too. So the step 1 is to take this 8 here and to divide it in half to get 4, because that's what we ended up putting on both sides of our x squared square. And then to figure out what this number was, because that was our length and our width that we were adding, we square it. 4 squared is 4 times 4, which is 16. This number is what goes in the blank. So that's C. Then, if they want you to write it as a perfect square trinomial, what we have to do is take this and factor it. So if we're thinking about how we've been doing factoring, we're multiplying to get 16 and adding to get 8. Well, that's 4 and 4. So you could write it as x plus 4 times x plus 4, or we can make it x plus 4 squared. And so what we did is we wrote this now as a perfect square. So this was C, and then I should just put a step 3 is to factor, and step 4 write as squared. So I'll give you a second to write that down. Okay, so let's do another one. We'll do one that we did not model with the tiles because we didn't have enough. Let's do x squared plus 20x. So we need to find the number that completes the square. So our first step is to take the number that's in front of x, that's your middle term, your linear term, and divide it by 2, which gives us 10. And then we're going to take 10 and square it. So 10 times 10 is 100. So this is the C that they will ask you for. And then they will want you to write it as a perfect square. So step 3 is to factor. So we make our x. I'll do it over here. We're multiplying to get 100 and adding to get 20. So that would be 10 and 10. So x plus 10 and x plus 10 is factored form, and then step 4 is to write it squared. I don't know how I want to word that. Write it as a perfect square is what I think it says on the assignment. So we're going to write it as x plus 10 squared. Now you can use this also with negatives. So let me show you that. I could have x squared minus 12x plus something. It works the same. You're going to take negative 12 and divide by 2 to get negative 6. Then when you square it with a negative, we always put it in parentheses, especially if you're doing it on the calculator, because negative 6 times negative 6 should be positive 36. So that's the C part of our quadratic expression here.
Is it okay if you borrow one of your hole punches?
And then we're going to factor it. So for factoring it, we'll make the x, and we're multiplying to get 36 and adding to get negative 12. So that would be negative 6 and negative 6. And we can just go ahead and write it as x minus 6 squared if you want to keep this as simple. I feel like we probably don't have to write these steps out on everyone, but with the first couple of steps, it's nice just to see where those came from. And then I'm going to do one where they don't divide evenly. So I'm going to do x squared plus 11x. And we're looking for C. So when we take 11 and divide by 2, you're going to get 5.5 or 5.5 or 11 halves. Depending on how you want to write it, it's all the same thing. And then you're going to square it. So if you're using a calculator, you can just do 5.5 squared, which is, I'm not even sure, I think it's 30.25. Good, I did that mental math correctly. I wrote it differently last year, so 30.25 is what's going to go here. You couldn't model that with the tiles very well because we'd have to break one of them into quarters. And you'd need 30 of them, so, you know, there you go. So when it's time to factor it, factoring 30.25 and 11 seems a little daunting, except that there's a trick. Whatever you got on this step, we squared to get this number. So this number, when I add it together, makes 11, and when I multiply it, gives me this. So we've already kind of worked it out. So this is C. We need that answer. We still have to go through those steps. So that's C. But then you actually already have the number that you need here from your first step. So this is going to go here, and this is coming from up there. And that will be it. All of a sudden I couldn't find the screen to push stop.